Now we see the differentiation of implicit function. Y is said to be an implicit function of x if y cannot be written explicitly in terms of x, as in y equal to f of x. So that means if we cannot write y and x on two different sides of an equation, or we cannot express y entirely in terms of x, but x and y are still related to each other. So in that case we call y as an implicit function of x. So as an example, here we have cos of x plus y equal to 2xy. So here we will see that it will be not possible to write y entirely in terms of x by whatever transpositions or whatever operations we do on both sides. So therefore here we say that y is implicit function of x because y is still dependent on x, isn't it? They are related by a particular relation. Now how to differentiate y with respect to x if it is an implicit function? So to differentiate an implicit function y, we differentiate as usual throughout the equation and then separate the term dy by dx. So there is no different rule or new formula to differentiate implicit function. We just go on differentiating assuming that x and y are the functions of x. Alright, so we use all the known rules and separate the term of dy by dx on one side. So interestingly, we will observe that the derivative dy by dx will typically include x as well as y in its value, right? So let us see some of the examples which have implicit functions. So firstly we have to find the derivative of y with respect to x, where sine of x plus y is equal to xy. So we observe that here once again y is an implicit function. So to differentiate, what do we do is we straight away differentiate both sides. So on left hand side, derivative of sine is nothing but cos. So we write cos of x plus y, but multiplied by, we have to also write the derivative of x plus y using the chain rule. Now derivative of x is 1 and derivative of y is nothing but simply dy by dx, right, is equal to, on the right hand side here we see that it's a product of x and y. So we use the product rule, that is first function x as it is into derivative of second function which is dy by dx plus second function y as it is into derivative of first function, that is derivative of x, which is 1. So therefore here we have cos of x plus y plus cos of x plus y into dy by dx is equal to x dy by dx plus y. So taking dy by dx term on left hand side so that we can collect all the dy by dx terms, and taking the cos term on right hand side by subtracting. So on left hand side we take dy by dx common, and what remains inside the bracket is cos of x plus y whole minus x, isn't it, is equal to, on the right hand side we have y minus cos of x plus y. So therefore finally we get dy by dx as, on the right hand side we have y minus cos of x plus y divided by, we'll have to divide it by the factor cos of x plus y minus x. So that's the final answer. Now let's see one more variety of the question. Sometimes rather than finding out the derivative, we are asked to prove that its derivative equal to some expression. So if x square into y cube is equal to x plus y whole raised to 5, then show that dy by dx equal to y by x. So here once again let us begin with differentiating the left hand side. So the first function x square as it is into derivative of y cube will be 3y square into dy by dx plus y cube as it is into derivative of x square, which is 2x. So that's the differentiation of left hand side, is equal to, now on the right hand side we have x plus y whole raised to 5. So its derivative is 5 into x plus y raised to 4 multiplied by, we'll have to write the derivative of x plus y itself, isn't it? So which is nothing but 1 plus dy by dx. Now simplifying further, we have the first term as 3 x square y square dy by dx plus 2xy cube is equal to, on the right hand side let us open the second bracket because we'll have to separate the dy by dx term. So the first term will be 5 into x plus y raised to 4 plus, in the second term we have 5 into x plus y raised to 4 into dy by dx, right? So therefore we collect dy by dx on left hand side, so therefore doing that we can take dy by dx common and we'll be left with 3x square y square minus, the term coming from right hand side is 5 into x plus y whole raised to 4, so that will get subtracted. This is equal to, now the right hand side is left with 5 into x plus y raised to 4 minus 2xy cube. So now therefore we have to just divide by this particular expression, correct? So therefore dy by dx is equal to 5 x plus y raised to 4 minus 2xy cube whole upon 3x square y square minus 5 x plus y raised to 4. Now if you observe on the right hand side we want y by x, which is a very simple looking expression, but what we have obtained so far is a rather complicated expression, and that too if you observe we have x plus y raised to 4, alright. Now obviously we cannot use the binomial expansion and expand that, it will become too tedious. So rather than that we have a simple shortcut or a smart trick. What we can do is, we observe that the given expression contains x plus y raised to 5, that is just 1 degree more than what we have, isn't it? So let us multiply numerator and denominator by x plus y, so that we will get x plus y raised to 5 in the first term of the numerator as well as second term of denominator. So therefore we multiply both numerator and denominator by x plus y, so that the first term becomes this. Now to the second term we have to multiply by x plus y, correct, divided by, here also the first term 3x square y square will get multiplied with x plus y minus 5 into, the second term will now become x plus y raised to 5. So that further gives us 5 into, now x plus y raised to 5 can be definitely replaced with x square y cube. So that is 5x square y cube minus, now let us expand that second term. So here we will get 2x square y cube minus 2x y raised to 4 whole divided by, below also let us expand the term, we will get 3x cube y square plus 3x square y cube minus 5 into, once again let us replace x plus y raised to 5 by x square y cube, right? So now we collect the like terms, that is 5x square y cube minus 2x square y cube, that gives us 3x square y cube minus 2x y raised to 4 divided by, in the denominator the like terms are once again x square y cube and x square y cube. So that gives us, first term is 3x cube y square minus 2x square y cube, right? Now let us simplify that further. Right. Now we take x y cube common from the numerator, so we will be left with 3x minus 2y whole divided by, in the denominator we can take x square and y square as common, so in the bracket we'll be once again left with 3x minus 2y, right? So therefore on cancelling, outside 1x will get cancelled and y square will get cancelled, leaving y by x as required, right? So that is how we use the differentiation of implicit function.